Okay. So, good morning, good afternoon, good evening, depending on where you are joining in from. Thank you for giving us the next 40 minutes. This is TechGrit Talks, our monthly webinar series. Today's topic is beyond the mainframe, and we are going to show you how we re-engineer legacy COBOL into C Sharp. So before we get started, I'm Dinesh Tigala. I run IT service and delivery TechGrit, which is a way of saying I have been close enough to enough modernization initiatives and engagements to have some strong opinions on why they succeed, why they fail, what needs to be done. And with me, I have today Ashok Kota. Ashok Kota is our applied AI lead. Ashok brings close to 15 years of enterprise application building experience. Ashok is the person who's behind building these AI pipelines and then these custom skills that you see behind the pipelines that makes things possible. He in a modernization initiative, he's the one who owns the output quality, and today he's gonna run the bulk of the demo in here. Ashok, do you want to quickly say a couple of
Yeah.
sentences about yourself? Yeah.
Hi, everyone. I'm Ashok Kota, as you know, and I'm a lead applied AI at TechGrit, okay, where we help modernize the legacy software using the AI, okay. As Dinesh mentioned, I have 15 plus years of experience into software development. Lately, I have been focusing on figuring out how to actually put the AI into a real engineering teams, okay. It's not only like telling hype on anything, but practically how we really save the time and the real problem solving using the AI. That is what our intention and increase the productivity. That's all about my role in Integrate. Yeah. Thank
Thanks,
you,
Ashok.
Dinesh.
Yeah, thank you. So before we jump in, as part of today's agenda, we will run the next 40 minutes. I mean, we are going to focus more on the live demo that Ashok is going to show. But before we get there, I would like to take a few minutes, one, to talk about TechGrit, and then talk about the actual methodology or the method behind this madness on what we follow as a framework, and then quickly talk about the engagement and the case study, and then go to the live demo today. Uh, with that said, couple of housekeeping items before we jump into the deck here. If you have any questions, please post it on the LinkedIn Live or the Zoom chat here. So I'm gonna surface it out as necessary, as appropriate during this session. Okay, so at TechGrid, I would like to quickly cover what we do, who we are, what we do, and how we work with our clients. We typically work with our typical clients are mid-market companies who are into health tech, fintech, and construction tech. And we deploy AI first, AI accelerated engineering teams for our clients, not a large team of juniors or not just a team with a simple Copilot license, which is a different approach, different outcome. How we show up, how we work is we become part of our client teams where we work with solution architects, tech leads, and the client subject matter experts. And the question we try to answer together is how do we modernize a platform, or how do we implement a platform and scale it so that it holds for the next decade or two. So the core of this is the clients bring the institutional knowledge, and then we bring the modernization and the implementation expertise. So with that said, as we are focusing more on the COBOL, which is, as you already know, which is one of the legacy core platforms, and as we've been seeing among these modernization initiatives, Les, it's typically concentrates more on the regulated and the mission critical industries, as we can say, and it's with a good reason, because all the mission critical industries, all the mission critical applications, as it's become legacy, nobody dare to touch them because of the lack of documentation or the test coverage or the tribal knowledge, for many reasons. But where we see especially mainframe in the COBOL applications is in the banking industries and the insurance underwriter platforms and then the healthcare platforms that we see. So that's what we wanted to talk today. What does it take for us to modernize a COBOL platform, especially HR and a payroll platform? So before we get to the actual framework, I would like to quickly touch upon some forces that triggers the modernization effort, as well as squash some assumptions on what is a modernization about. So we, based on our experience, we typically see there are three forces mainly that drives, or it's a trigger for any modernization initiative for our clients. One, the talent supply. Mostly the people who know the system are the same people who keeps the team running or the project running. The people behind them gets thin every year, and the supply on this legacy stack reduces. There is almost no replacement pipeline at the entry level. So what happens in a typical day? Feature development competes with daily operations, and daily operations always wins. And the biggest other biggest force I would say as a trigger would be the release velocity. Legacy technology comes with legacy tooling, space documentation, and not enough test coverage, and it has the trickle down effect where every change carries that regression risk. So what ends up happening is that longer release windows or the change windows that we see. The third force is a compliance and capability force, which is where people are rather forced to than they make a decision on their choosing on their own. In terms of the complaints, will be a mandate from the government where you have to fix something with, but like we talked about the choke velocity, it becomes a big problem. From the capability standpoint, for example, you have a legacy banking platform and then you wanted to join a real-time payment network, but your architecture doesn't support, where you are put in a situation where you have to like take a decision like where delay the feature which causes a business, or you build a workaround. Again, it's a technical debt. So, and in terms of the assumptions, since we talked about the forces and the triggers, in terms of the assumptions, a modernization effort is not a full rewrite on day one. It's not a big bang release. And we are not going to abandon any modernization platform, especially the mainframe, on the day one or day zero. Or we do not start from zero. We start on the existing business rule sets, and it's not a feature freeze. A sequenced plan exists precisely for this reason, so that there is no freeze. So these assumptions, the reason that we are talking about assumptions is that, right, we wanted to talk about this framework that we follow here for any modernization initiatives and how it helps us in any initiative. So we have an orbit framework at TechGrit which have 5 layers. Each layer is integrated with each other. We have a start layer where there are two gates where the business can get into an AI impact method, or if you already know what you're doing, you go through TAMF, and then there is a structure and then 4D methodology. And then there is a scoping layer, and then there is the actual engine that runs this framework, and there is a ground that we have a reference framework that we deliver against. So I would like to hand it over to Ashok to like talk about each of these layers.
Yeah.
Go take us through this framework and explain us how does this framework drives this any modernization initiatives that we have.
Yeah. Can we jump to the next slide? There we can talk about the
Okay.
first layer. Okay. So in the first layer, right, we have two different concepts are there. One is the AI impact method and one is the time F. So AI impact method is like it's a starting point if we not decided what we really wanted to do, okay, or what how the way we want to use the AI or any improvements, then it is a starting point where we'll start the like all the analyzing everything will start from the AI impact method. Okay, that is the way we start this particular framework. And coming to the TAMF, TAMF is the framework we build from in the TechGrid side. It's like a migration purposes, like a .NET migration, COBOL migration, or any software upgrades. Those all processes we follow for the TAMF, where we will access the code. We will classify the code into a different metrics, scoring them. Okay, example, by the value, by the risk, by the readiness, and by the dependencies. We will score the code. Like, okay, this particular module is having this much of complexity or this much of risk is there. Those type of all the classifications we will do in the TAMF first. Then we will sequentize like how this entire order should be followed. Once we have the access and classify the whatever the project we are going to do the migration, then we will hand over that particular point into a 4D methodology. So TAMF help us here to analyze the entire process, okay, and score it, classify it, and hand over to the our 4D methodology.
So,
So
Ashok, like the classify stage here, right?
yeah,
Time of
yeah,
method, it's doing some heavy lifting where you are scoring
yes,
and risk register, and then you're scoring
yeah.
the readiness. Like, what does this scoring mechanism looks like on
So
this?
we generally depend on like how we score is like we check how many lines of code in the this particular module. Okay, what are the
Mhm.
different modules are there? What are the different integrations are there? What is the we have a dependencies are there? Okay, and is it a complex code? Is it a the when where exactly this module is used? So those all things will keep in our mind. Based on that, we will score the that particular module or that particular section of the code, logic things.
Does it differ from, for example, since we are talking about COBOL
Yes, yes,
modernization, right? So
yeah.
does it differ from COBOL to BBX or COBOL to Java or any
The
other
the
modernization?
the, the framework, the process will not change. It will change
Mhm.
based on the different methodology, the different modules, and where exactly this module is used. Based on that, we will score it the entire process.
Okay, okay.
Yeah, yeah.
Got it.
Okay, so when we talk about the 4D methodology, right, this is our main layer two, and this is the starting point in the real development team, and the other team members will involve here. So in the 4D methodology, we'll call it as discovery, define, design, and delivery. So this all goes individually. And when I gave the demo, when we see the demo, right, we will explain more about how this all 4D methodology works, and how this will help us to do the entire process into a streamline. Okay, example discovery. When we say discovery, we will do the analysis of the entire existing code base and will make them in the plain English process. Okay, and when we do the define means whatever we generated the spec plain English, we will analyze with the stakeholders, we will analyze with the SMEs. Okay, what all we can keep in this and what are the dead code is there. So those all analysis will do in the define, and something is the dead code or something we are not really using in the process, we will kill those processes. And then we will have a proper finalized spec will be there, which is approved by SMEs, approved by stakeholders. Then we will design the next modernization technology where we build the full blueprint. If example we are going from COBOL to .NET, we will build the blueprint from the uh, .NET aside, like what is the designing pattern we are going to use it, what is the tech stack we are going to use it, what is the framework in the .NET we are going to use. Those all will be designed in the stage 3. And the stage 4, we will create the specs and then we will do the delivery of the COBOL to C Sharp. So we'll follow the step 2, step 4 to receive the migration. And this is
Mhm.
what the our 4D model
But
says.
more than that, when you're working with the legacy systems, right?
Yes.
Like
Yeah.
they have this solid set of business rules, but
Yes.
there are like these workarounds that were built out, which technically I say tech debt item
Yes.
that, but how do you, I mean, what is the gate where we will make sure that those doesn't pass through onto the new platform or the modernized platform that we are building?
So that is what in the previous slide we mentioned we are going to do the scoring, right? When we do the
Okay.
scoring, we also had the all the risk and dependencies. If something
Mhm.
is in the COBOL, we are doing in a different way. Those all will keep as a risk patterns are dependencies. And when we are
Mhm.
doing a stage 2, you're defined, right? This is the
Mhm.
main stage where our developers, our BA, and the SMEs from the who written the previously written this code or who have the full understanding of the application, right? We all together sit and we'll go to the all the spec. We'll understand these are the really these functions are really we are using it. Is it a dead code, or we are not at all using, or these business rules we can take out and we'll add new business rules. Those all discussion we'll do in the stage two and the defined place. Once we
Mm.
discuss and we'll kill those all processes, then we'll go to the next stage. This is
Okay.
what we do in the stage two of the 4D model.
Understood.
Yeah.
Understood.
Yeah, this is about our we for the demo purpose, right? We took the one small case study called the payroll platform organization, where we have the payroll reporting is there, and right now more than 100 employers are using this particular application, and we took the small part of the payroll. It's a big HR payroll management system. We took the one part as a payroll system, and this code is generated around 3 decades ago, and we are now trying to do the migration, and we tried it, and that process is going on. And
Mhm.
the main thing is we have a less documentation, the stack problems and batch processes will happen, everything those all we are overcoming in the our new processes. So one big help here is when we are converting the cobalt into a spec, already we got the full documentation that is help us in the next 30 years. When you redo the again the new framework, this spec will help in the future.
Mhm.
Yeah.
I just wanted to add one point for
Yeah.
people watching here, right? So this particular project that we did, so the payroll is a particularly very unforgiving domain, I would say, because there are rules that apply along multiple axes, right? Every industry or the employer has their own rule set within their payroll systems. And then like every state has its own rules. And then every country has its own rules. So multiplying that across 100 plus employers and then like across different states and then different countries, right? It's just what the system is. I mean, like, but I just wanted to like recognize the fact that payroll is a system that's very unforgiving in its nature, and modernizing COBOL is a very big effort. Yeah, that we undertook here.
Yeah. So our Prism entire engine, right? The Prism engine will follow the our 4D methodology, and it will follow. And what exactly happen is we will read the Cobalt code and we will pass that into a plain English. We'll do the intelligence there, and we'll have a flags if something is not really looking good, or the business rules are not as following as the standardization of HR management tools. Those all flags happen in the intelligence. Okay, in the intelligence, we will kill all the process of the flags. We'll raise the flags. We'll talk to the SMEs. Okay, and we will discuss them. We will decide. Okay, these are business rules can be. We can keep it. These business rules can be. We can take out and we can add a new business rules. Those all intelligence we can do in the stage two. And the last stage, once we validate all the things, we'll create the final spec, and all the dependencies and all third party things, whichever we are using as a API contracts or data models or anything, we will add them into a spec and we'll create the final spec for the process. And we'll provide this final spec into a uh, for the last stage of delivery.
Mm-hmm.
Yeah.
Yeah.
So we are going to see the skills or the pipeline which we created for the 4D model we are talking about, right? In that we will have a six different skills we created from ourselves. We can call it agents, we can say, or skills, we can say. We can say like a COBOL parser, which is like a will read the entire code base and convert into a plain English. Then we'll make it as a spec. Okay. Then we'll kill or add in new rules or business rules. Everything will do the define. Okay. That is a one more skill. Okay. Then once the spec is ready, we will generate the code. We'll have a separate skill for that. Okay. Okay, in the as Dinesh mentioned initially, right? In the COBOL, we don't have a test cases or we don't have any proper test handling and everything, integration testing and everything, right? But when we are migrating into new technology, we are going to add these additional parts as well. We are going to have a proper test cases, integration test, and everything is following as per the respect to technology standardization. And also we'll have a regression testing and everything is a part of the fourth step of the delivery.
So,
This is
Ashok,
our, yeah, go ahead. Yeah.
how reusable are these skills? One, you already have this skill built out. How
Yes.
reusable are these for another COBOL modernization? And how reusable are these skills for another modernization from a different tech stack altogether?
So when we talk about any other modernization for the COBOL, right, the entire pipeline does not be changed. Okay, or whatever we are doing a discovery, it will be the same. Only is the when we do the validations, the manual validation will do that. That business rule checks and everything happen as a manual. Only that process may change based on the different way of presentation
But
from the
does
different
it, does
way.
it, for example, the spec extractor skill, right? Does it,
Yeah,
when you're going from this one project to another project,
yeah,
which is again a COBOL
yes,
platform,
yeah.
how will the spec extractor skill will change? Will it change or will it stay the same? That's my
No, for
question.
the same technology, this will not change. That the
Okay.
pipeline is same for the same technology. But when we are going for the .NET or when we are going for Java, then
Mhm.
the spec extraction will be changed because we have to mention this is related to COBOL
Mhm.
language, this is related to .NET language. If this
Mhm.
.NET language, we have to convert this one in this particular way, and we have to mention
Understood.
in this particular conditions and everything, right? That
Mhm.
particular spec extraction will be the change in the language to language. But after that, whatever we do the process, okay, we did the discovery. Okay, when we are doing a define, there is no change in the define. Okay,
Mhm.
then again, when we do the design, then there is a change will come in the different technology because .NET design will be different because .NET follows the different design patterns. They have a different frameworks will have. Okay, example .NET framework and .NET code and the presentation and writing the test cases and everything will be different pattern for the .NET. When it's coming to Java, when it's coming to Node.js or Python, the pattern will be changed. So
Mhm.
design and the discovery will be changed, but define will be same. And when it's coming to delivery skill, that will be changed entirely because it's also respect to the technology because we have to map from the COBOL to respect to language, right? That also will be changed.
Okay. So I have
Yeah,
a question in the Q&A, Ashok. I know we have a live demo to go through, but it's a
yeah,
good
yeah.
question. Like you have you have a big backlog of defects in your
Yes,
COBOL platform
yeah,
already,
yeah, yeah.
which you have been sitting on. How do you make sure, or where does this framework come into picture? How do you make sure the defects are resolved in the new platform, or does it carry over? The bugs are carried over into the new platform. How does it work? Where do you
Oh,
actually like think about
this
it?
this is really a good example we can say like when we did the okay example pass spec is ready and we removed the all unnecessary code. Now we have the final spec is ready, which is SME approved. Now if we want to fix the all the bugs in parallel to the new migration, right, we can integrate this all new bugs as a part of our spec. If we include them into a part of our spec when we are doing a development, the spec driven development, this all we can fix them in the part of the new development, new migration.
Okay.
Okay, so it should be like it again, the SMEs, the BA and leads should aware of what are these bugs and where these bugs can suit. That analysis should be happen upfront. Okay,
What about the bugs that nobody knows about? Like, you know, the bugs
so
that
that
we
is,
have a backlog is fine, but
yeah.
nobody knows it's a bug until
Yeah,
you
that is the reason, right? That is the reason I will give in a good example, right? We did the same process for another application. It's an Android application. We wanted to
Mhm.
migrate into a latest technologies. Okay, so
Mhm.
in that process, when we created the entire spec, okay,
Mhm.
and when we presented this spec to the client at
Mhm.
SME, okay, what
Mhm.
happened, right? They mentioned, oh, this feature never worked for us, but the code says this is working.
Okay. Okay.
Okay, those type of when we create a spec, right? Those
Mhm.
type of all the conditions in the code, there will be a lot of conditions will be there, which
Mhm.
we in the front end we can't see them. As a user, when they're running in the application, they can't see all the conditions. Those all will be
Mhm.
captured in the spec.
Okay, okay, got it.
So
So I,
yeah,
mhm.
yeah, yeah. In
So
the
I want to.
I just want to add one point here, right? Like whatever we see in the as a user in
Mhm.
the back end, there is a lot of other logics are there. Okay, those
Okay,
all will be captured in the spec if we do the
okay.
conversion. Yeah,
Yeah. So I want to be very cognizant about the time. We only have 20 minutes, Ashok. Why don't we
yeah,
jump into the demo and then
yeah,
move from there?
yeah, yeah. Okay, so I just share my screen. Okay, give me a second. Yeah, you can see my screen, right?
Mhm. I can see it. Yep.
Yeah. So we, for the demo purpose, what we did is we created the demo project in such a ways that we can see the end-to-end process. With in
Mhm.
the like just we have a 15-20 minutes, we can't run the all the skills and all the artifacts and show the entire demo, right? What we did is
Mhm.
we we segregated this entire into a legacy code base and what are our prism skills we defined and when we run these prism skills what are the artifacts are going to create it
Mhm.
when we do the final migration the final stage when we do the in the 4D model when we do the final migration how the .NET code will be look like. So we
Mhm.
did all upfront for the demo and we'll explain one by one step what exactly the process will happen in our system. Okay, in our
Mhm.
pipeline. Okay, so this is our cobalt code. Okay, this is our cobalt code as we took as a legacy cobalt code and this is the program we are going to do it is a payroll calculation. This is our cobalt code and this is the payroll calculation. What exactly happens when you run this payroll, right, payroll system? We can see the payroll the payroll for the each individual employee. Example, Smith is the gross salary is this one, is paying the tax, and the net salary will be this. So these all the records will be stored in the database, and will get those records whenever the this COBOL program runs in weekly or bi-weekly. Whenever they run, we'll get the data from the respective employees information, and we'll calculate and everything and report, generate the payroll report. So this is what this entire this small module will take. So what we do is when we come to the prism, okay, in when we come to the prism is follows the four as we talked about four different models, right? One is discovery,
Mhm.
discovery, define, design, and delivery. Same, we created the four different agents or four different skills we can say. Okay, zero one is discovery, define, design, and delivery. So these skills we created from our site. Okay, we took the references from the different migration processes. Okay, from published by different Microsoft, Azure, uh, AWS. They publish their own how they are doing the process and everything. We followed the similar processes here, and we while we creating these skills we added the few more additional uh, skills like example from the Git, cloud published couple of the plugins. We took the plugins helps and we created these skills from our side. Okay, example
Mhm.
prism discovery, what this exactly talks, this will talks what is the code base for us. Okay, what it have to generate. Okay, what are the different uh, uh, reads it have to do it. Okay, and what is the ground things it have to keep it. No uh, blindly assumptions or anything. It have to properly talk to the code and get the information and how the output should be look like. Okay, and what are the different rules and what is the flags, how the flag should be raised. Okay, something in the cobalt code mostly will see the hard coded values, so those all it will flag. Okay, when we do the designing and designing, right, that time we can remove this all coded values and make it as a dynamic. So those all information we will keep in this skill. Okay, and when we do run this skill, prism discovery skill, okay, what is the artifact we get it, we will get the discovery spec in a different type of modules. Okay, it's not like a one single spec will come as a full module, right? It will come as a function by function specs comes so that we can easily read the each and every functions. Okay, example, if you go to the payroll calculation, right? So this is the business, what exactly this business is doing it.
Mm.
So when we run the discovery mode, right, this is what it will generate as the artifact. Okay, so we'll see the full business. What is the business? It's okay. What are the different rules it is following? It means different condition, whatever we are talking about. Okay, and this is about the functions. Okay, then it will do the flags. Okay, it will also flag, okay, this particular condition is not correct, or it's not, I'm feeling it's like a flag for me because multiple conditions are there and it's showing 0 1.25. We don't need those all information, it's raised different question for us.
Mhm.
Okay, these are the flags. So once we got these flags, right, in define mode, okay, in the define mode we can discuss with our SMEs or BAs as stakeholders and discuss this all the flags. Okay, these are the flags we got when we did the discovery. Okay, is it correct? Oh, we can skip this one or we can override this one. Those all discussion we can do in this particular pattern. Okay, once the define we done with the define, then we will do the design. Okay, in the design we will mention, okay, these all our files which is created in the spec folder in the artifacts. Okay, read them. Okay, then this should be follow or new, it should follow the new technology, example .NET. Okay, whatever the .NET standardization, example, we are going to have a solution. Okay, in the .NET, we are going to have a solution, then we are going to divide them into a different patterns. Okay, example, domain. Okay, in the application and the infrastructure. Okay, and the CLI. So we'll define the different subclasses. Okay, so that it will be clean code. In the COBOL, everything is in the one function. We are dividing them into a different sections here. Okay, once we define the all, we'll design everything here. Okay, and when we run this one, this particular one, it will create the architecture. Okay, it will create the architecture for us, how the entire cobalt code will be migrated into .NET, how it will look like. That architecture should be visible to us here. Okay, then we have some contracts. Okay, these are the different uh, the output and input, whatever the parameters we are going to get, it will be show here. Okay, and the domain model. Okay, and the domain model. Okay, this is how the artifacts will be generated. So we generated this upfront to the demo for the all the 4D model. Okay, prism discovery is done, define, design. Now the delivery comes. Okay, when I run this delivery, okay, this particular skill, this particular agent, okay, it will read the all the artifacts which we generated. Okay, okay, example, define, design, all these
Mhm.
artifacts it will read, and it will create the one regression report. Okay, this is what I'm going to generate it. Okay, and it take the approval from us, and then it will migrate the entire code base.
Mm.
Okay, and I will just show in the .NET Visual Studio. Okay, it will create the all the code base converted here. Okay, and also it creates the all the test cases which is required for the integration and the unit test cases. Okay,
Okay.
then I can just do the run test cases, all test cases are passing or not, I can verify.
So, Ashok, I have one good question from the
Yes.
Q&A here
Yeah.
again, which is very
Yeah.
relevant to the testing. So the question is, do you use the old functional test cases to validate the new migrated version?
Yes.
Or, so I know you mentioned there is no test coverage here, but in terms of a general modernization
Yeah. So what we
implementation.
generally we are following here is, so
Mm,
whenever we run any COBOL program, right?
mm.
Example, I will show the give me a second, the Prism artifacts. I'm not getting the file. So what happens, right? In the when we run the COBOL program, so every
Mhm.
time when you run, you will get the test result there. Okay.
Mhm.
Same data is coming from the database. The database changes. We're not touching anything, right? The database is safe. Okay. When we run in the Cobalt, we are getting this example. We have report, right? Yeah, payroll report. Okay, we are getting this result. The same test if I'm running for the .NET, because we are not killing the process right now. We are not shutting down the entire Cobalt immediately, right? We are keeping
Mhm.
the Cobalt there, and the .NET we are parallelly
So,
building it.
Ashok, sorry to cut you off there. Like, I think the
Yeah.
question is more about you might have your functional test cases in an Excel
Yes.
sheet or in a test trail somewhere.
Yes.
How
Yes.
how do you reconcile that with your skills and the spec extractors and then like how in within your artifacts?
So if already under the Cobalt having a test cases written, okay, that
Mhm.
also we can pass into our discovery mode. When we pass those
Mhm.
into discovery mode, it will
Mhm.
compile and it will convert into our unit test cases.
Mhm.
So
Okay.
that is what right now when we created this
And
test
does
cases.
it also generate the functional test cases?
Yes, yes,
Here?
yes, yes. So right
Okay.
now, whatever the test cases are created, these are based on the code. Okay,
Mhm.
but
Okay.
if we have a test cases already written,
Mhm.
that can be generated using our skills. That is a
Okay.
part of the spec, and we can also validate these are the correct functional test cases or not. This all we can validate.
Got it.
Yeah,
Yeah.
yeah. And if you see, all test cases got passed here. Okay,
Mhm.
and this is what our 4D pipeline look like. Yeah, discovery, define, design, and delivery.
Got it.
Yeah. Any question on this one, Dinesh?
I don't see any open questions, but we will take it at the end in the
Yeah,
Q&A if there are any.
yeah, yeah. Okay. Uh, can we continue?
Yep, I'll share my screen. Okay, thanks for the demo, Ashok. Just give me a second. Okay, so can we talk about like Ashok, like we talked about what goes right and then like what is the happy path and like we talked about some kind of like quality gates and everything, but
Yeah.
what is it that you keep an eye on, like what can get wrong
So
during these modernization
when
projects?
we generate the spec finalize, right?
Mhm.
That is the point is the main important when we are doing a migration, because everything start from there. That is the source for us to generate the
Mhm.
code. That is a source for us to continue, right?
Mhm.
There we have to validate properly every business rule, every functions, and every uh, requirement, whatever is there, it's correct. Okay.
Mhm.
And in our development process, we follow the spec driven development. Okay. In the spec driven development, entire tickets, entire story will take in the function by function. So
Mhm.
the main thing is the logics are correct.
Mhm.
Okay. And is there any dead code is there?
Mhm.
Okay. And no assumptions are there. So these all things we will keep in eye. Okay. Before we start the development, we will create the spec, plan, and task, then we'll continue for the development.
But are there any patterns that you see, right? Okay, 90% of the time the AI does get it wrong. I know you have the quality gate and then
Yes.
you're doing it, but are there any patterns that okay, these are the things that the AI mostly will get it wrong, or these are the things that we have
The
to
couple
keep
of condition business rules will be there, right? In the cobalt we may written with the static, as I mentioned in, right? In the cobalt, mostly all the parameters mention the static values and everything, as we saw, right? There is a, if the one, there is a 001, if two, there is a 00. Those all we are making this a dynamic here, okay, in the
Mhm.
C sharp, right? So
Mhm.
those when we converting the static into dynamic, we should be very careful, like exactly we are converting or not, all the businesses are following or not, that we have to be very careful on that particular part.
Hmm. Okay, okay. Is there anything that you definitely refuse to let the AI decide, or definitely like one thing that you have to like review every time, keep
uh,
an eye on? I know you talked about mostly a lot of things, But one thing that you have to pinpoint.
No, as in a process in our system, we will nothing will take whatever is generated by AI. Everything should be go as a reviewed and standardized process. Okay.
Yeah,
Yeah,
yeah, yeah.
yeah,
So thanks, Ashok. Thanks for taking us through the demo. And as a quick recap, right? I mean, like whatever that we are seeing in this modernization effort or the initiative or any of these modernization efforts, right? We see that split of like 40, 30, and 30, where
yeah.
you were mentioning that engineering judgment, engineering
Yes,
direction, and manual
yes.
quality gate is the definite thing, and that takes up around 30% of
Agree.
this whole effort. And we have some stats here that was the outcome for with this engagement here, where we reduce the cycle time, where there is this reduced turnaround time on how we are squashing the bugs, how we are implementing the new features and all. So I wanted to quickly touch upon this layer three, or the fixed scope, right? Typically, like how we get into a project, or how we assess a project, is two types. One, we do a simple pilot. We ask the client, hey, are there any most very important sample programs, or is there a varied version of like three or four good set of the sample progress that you can give us? That's more kind of a mostly a reflection of the entire set of the programs, and then we run a quick pilot with all of the existing frameworks that we have. Okay, and then we summarize it and then we deliver it. That's one thing. And the second way that we also do this phase zero assessment is that, right, instead of doing a sample set, we directly take the full code as full code base, and then like do an inventory of it. Okay, and then we come up with these artifacts of this technical architecture blueprint, and then like we do come up with that, what is the time and then effort, what is the team does it take for us to actually like act upon this, like implement this modernization effort, or take this modernization effort forward. So this is kind of, this layer sits in the middle after the start and the structure, and then this is where we scope things, and then like go into the engine, where what you saw Ashok doing it, right? This is where it sits together. So with that said, that concludes today's session. We have 2 more minutes, but if you guys have any questions, please drop it in the chats. Oh, I see some questions.
Yeah, there is some questions. Yeah.
Okay, seems like you're migrating static code. Is there any risk of new issues coming up at runtime?
Not really like it's not exactly the static code we are doing it. Okay, it's all dynamic. Like we run the same program, same pipeline on the entire dynamic entire code base. So
Mhm.
it's come on the dynamic way. Yeah.
Okay,
Okay. Yeah.
I think we answered the rest of the questions here. Okay. So, people watching or people that watch in future, I mean, if you have any question, that a curious question, please drop it in the chat. I mean, when we make this session as a LinkedIn post or a YouTube video, you can drop in your questions, where we will keep an eye on, like try to answer as soon as possible. Uh, with that said, there are no questions at this point of time. But Ashok, thanks for taking us through that framework.
Yep.
And this video will be available on LinkedIn in 24 hours. Everybody will get the link over an email.
Yeah.
Uh, we learned, hopefully, people learned something new, took away something new on how we modernize a legacy platform, something like COBOL, into like modern tech stack. Thanks, Ashok, and thanks
Thank
everyone
you.
for joining us. I know your time is all precious. Thanks for giving us this 45, 50 minutes here and listening to us. Thank you so much.
Thank you.
Thank you.